Hello, good morning for me. But if you're watching this at night, good evening or good night to you. How's it going? You're up pretty late. What are you doing math? But you know what? If you're up late and you're only doing math, you're a good person. You are a good person. Anyways, we are on Unit 2, Lesson 12. This is the last lesson for this unit before we do the unit review sheets and the test that's coming up. So sit back, buckle in, make sure your seat is in the upright position and your tray tables are up because we're about to take off, people. Okay? We are going to start solving rational equations. We have been simplifying rational equations. And again, the word rational just means fraction. Okay? So, without any further ado, let's move forward. All right. First of all, how do we know we have a rational equation, okay? How do we identify a rational equation? A rational equation is, it's any equation, I'm going to abbreviate here, with a fraction. Okay, point blank. Oh, look, I have an equation that's an equal sign, and I have a fraction, so it must be a rational equation. There is no trick here. There is no, oh, hey, I got you. Ha ha. I'm funny. Wait till April Fool's Day. No. An equation with an equal sign, it has a fraction. It is a rational equation. So as I look at the following three math sentences, I will call them, which one of the following, or which of the following are rational equations? When I first did this, I'm going to be honest with you. I was like, oh, they all are. Because I'm looking and I'm loving fractions everywhere. But maybe you noticed this, maybe you didn't. This is a rational equation? Yeah. This is a rational equation? Yeah. This is not a rational equation. How come? There is no equal sign here. This is technically a rational expression. Okay? The second one does not have an equal sign. I can't tell you the number of students. I just went to grade Algebra 2 Regents that were taken in January, retakes. Okay? And I saw some of them on Part 2s make this mistake. And no doubt some people will always make this mistake, and it drives me crazy. They will say on a Part 2, 3, or 4 question, a short answer question, probably 3 or 4, one of the ending questions. Here's a situation, write an equation to model the situation. And maybe the answer should be y equals x plus 6. There's my equation. The number of people that just put x plus 6, and you've got to get a point taken off because it is not an equation with an equal sign. That drives me crazy. Equations need an equal sign. Need an equal sign. On a test, when it says write an equation to model the situation, you better have an equal sign. Don't lose those points. You're too smart to just give them up. So let's go to the basics. Before we start doing these things, forget about variables in our rational equations or expressions. Just basic fractions. How do you add them? Well, there's a couple things we need to do. One, we need common denominators. Okay, you always need common denominators. Okay, it says how do you add? This really could be subtract as well. Okay, add and subtract kind of are the same thing. You're combining. You still need a common denominator. Step 2 is when you have a common denominator, okay, you just add, or in our case, it's add or subtract, the tops, which we call the numerators. Okay, those are the tops. And then the bottom doesn't change. You don't, that's an M, you don't add the bottoms. Okay, the bottom doesn't change. Whatever the common denominator is, that's what it is. And the bottom, again, that's the denominator. Now, in order to find the common denominator, it helps to know factoring and multiples, okay? So multiplication, it's huge for common denominator. One quick side note. If I have a fraction, 1 over 2, If I'm going to multiply my denominator by a number, I always have to do the same thing to the top to keep it equal. 4 over 8 still represents a half. Okay, so this, do not forget, what I multiply the bottom by, I have to multiply the top by, the numerator by. Okay, so let's move forward. Do you need to check for extraneous solutions? Man, extraneous solutions. I remember extraneous solutions when we were solving radicals in equations. And every once in a while, if we get two answers, remember one one tried to work but didn't, and we just crossed that one off and we called it an extraneous solution. So now we have fractions or rational equations, okay? Are there any restrictions on the domain? The domain would be, in this case, if I look and I'm using the x variable, our domain are all of our x values, or whatever variable we're using. For fractional equations, yes, there are. Yes. My denominator in a fraction can never equal 0. If I do, it becomes undefined. And undefined fractions cannot be solved, and that's a boo-boo. Okay? So, try to solve this equation for x. Let's list our steps. I'm not so concerned about checking our answer at this point. Let's just make sure we know what we're doing. Now, there's no restriction on my variable. I have no variable in the denominator. So my x can be anything. Okay, so my bottoms will always be 2 and 3. They will never change. So they will never be 0 in this case. All right? So step 1, in order to get a common denominator, I want to make sure every term is a fraction. Every term should have a denominator. So let's make every term, turn that into a fraction. And I'm going to abbreviate here. So let's do that, step 1. Well, x over 2 is already a fraction. Plus x over 3, already a fraction, equals 10. In order to make 10 into a fraction, I'm just going to put it over 1. Boom, now it's a fraction. Okay? Step 1, every term is a fraction. Step 2, I need to find a common denominator. Now, a common denominator between 2, 3, and 1 would be 6. Okay? How can I make all these denominators the same? By multiplication. Okay? I need to find common multiples. And 6 is the lowest common multiple. So if I multiply a 2 times 3, that would give me a 6. But what I do to the bottom, I must do to the top. 3 times x is 3x. Plus, I can make my 3 into a 6 by multiplying it by 2. What I do to the bottom, I must also do to the top. And I could definitely make my 1 into a 6. What I do to the bottom, I must do to the top. And please note, 60 over 6 still maintains its value. That still equals 10. That's what we started with. So we really haven't changed the values. We've changed the way the fractions look, but they ultimately represent the same thing. Now, this is the part that I love. I love me this part. I call this part wipe out. Okay? Boom. I cross out the denominators, but I like to say bottom because it's funny to say bottom. Okay. I cross out all of them. And what I'm left with is 3x plus 2x equals 60. How does that work? Okay, what I'm about to write in red, well, let's make that purple. What I'm about to write in purple, you don't have to write. If I have 3 over 2 plus, I don't know, 4 over 2, don't I add the tops? That's 7 over 2. Did my 2 have any effect in what the top should be? No, it doesn't. That's the same rule that applies here. Okay, my x's are in the top. I'm still going to solve for x's with just my top. So the bottoms aren't going to have anything to do with anything. Whenever the bottoms are all the same and you're solving in an equation, boom, wipe out, done. Okay? So now let's pick this up and solve this. Now it is a basic problem. So getting from this point to this point, okay, that's the hard work. From this point on, that's the easy stuff. This is middle school, probably upper elementary at this point with Common Core, the way they push things down. Okay, finding the common denominator is the hard work, but we're going to try and make that a little bit easier. We'll try and go over these things so they sound easy. Then when you do them alone, you're going to be like, I can't do that. Don't worry, you can. Okay, so I'm going to combine these. 3x and 2x is 5x equals 60, and I divide by 5. So when everything's all said and done, x equals 12. Now, they told us to check this. We're just going to do a quick check because we're in Algebra 2. We should be able to check this quickly. 12. 12 over 2 would give me 6. Plus 12 over 3 is actually 4. 6 and 4 does equal 10. Okay? 6 and 4 does equal 10. So there's our check. Boom. All right? Good. It wasn't that bad, but this was an easy problem. I get it. But I'll stay with you when we do these problems. Don't worry, I'm not going anywhere. Example 1. List the restrictions on the domain, which means what can my variable not be? Okay? Restrictions on the domain. So my variable cannot equal what? That's what that means. Find out what your variable cannot be. Then find all possible solutions. Okay, so you see how they have this here that's nice? They have y cannot equal. Y cannot equal 0 in this case. What happens if I put a 0 in for y? I have a 0 in the denominator. Uh-oh, mistake, undefined, cannot do it. So I'm going to solve this. And if I happen to come up with 0 as my answer, that would be an extraneous solution because 0 cannot be the answer. So let's figure this out and go from there. Let's get everything in the fraction form. 6 over y is already a fraction. Equals. 4, we'll put that over 1. Now it's a fraction. Plus 10 over y. Now, the first problem wasn't bad. It was just numbers. We're stepping it up, and now we have variables. Love the highlighters. This is a y. This is a y. Wouldn't it be cool if this had a y? Then they'd all be y, and we could do them all. And that's exactly what we're going to do. I'm going to multiply this times y. What I do to the bottom of the fraction, I must do to the top. So I now have 6 over y equals 4y over y plus 10 over y. Uh-oh, wait for it. Bottoms are all the same. Pachow, man. Get rid of the bottoms. Why would you even keep them in there? Now this becomes basics. 6 equals 4y plus 10. This is where the easy work starts. Okay? There's only a little bit of this problem that's difficult. It's finding the denominators. Okay? And we're going to get into a part where we need to start factoring to make this easy. Factoring never goes away. All right? Let's finish this off. Subtract 10. Here we do. We'll do this in black. Subtract 10. Negative 4 equals 4y. Divide by 4. And y equals negative 1. Is that a restriction? No. 0 is a restriction. Y can be negative 1. That is not an extraneous solution. That is a great answer. Very good, very good, very good. More examples. Okay, number 2, let's list the restrictions on the domain, which, again, that means what can the variable not be. Then find all possible solutions for the following rational equations. And then it says check your answers against the restriction. So make sure what we come up with is not restricted. Okay? Make sure what our answer is not a no-no, as I like to call it. So if I know denominators cannot be 0, x plus 1 should not equal 0. I'm going to go over here. I say x plus 1 cannot equal 0. Because if it does, this expression, if that's 0, then the bottom is 0. So how do I solve it? Subtract 1. And I say x cannot equal -1. Okay? Some of you might have been able to do that quickly, but I'm just showing you the math behind it. If x is -1, what's -1 plus 1? 0. That can't happen. That's a no-no. So our special no-no for this case in our domain is -1. All right? So I am going to show you an easier way, and some people like different ways. Okay? When you have, and here's a little special side note, when you have one fraction equal to one fraction, what I like to do is I always cross multiply. You could do it the other way, and you would get the same answer. Okay? But the way I like to do it is cross multiply. Now, this is simple. We have another problem coming up that's one fraction equal to one fraction. And if you cross multiply, it turns into a monster. Okay? So I'm going to say if you have one easy fraction and one easy fraction, if your multiplication is going to be easy, I would definitely cross multiply. And in case you forgot, I'm going to take 2 and multiply it times x plus 1. So I have 2 times x plus 1 equals. Now I'm going to take 4 and multiply it times 3. 4 times 3. So distribute 2x plus 2 equals 12. I mean, my goodness. Cry me a river. Math is so difficult. 2x equals 10, and if I divide by 2, x equals 5. Gadoosh. Is that a restriction? No. So we're cool. X can be 5. X can be 5. X can equal 5. X is 5. All right? So if you have two easy fractions, cross multiply. Dude. Now, let's go on to the next one. Sorry about that dude reference, but, you know. I just saw the Super Bowl commercial with Jeff Bridges as the dude guy, and it's just, never mind. You'll get it someday. All right. All right. All right. Now, we have problem number 3 here. Again, stepping up. An opportunity for me to use a highlighter. I will never pass it up. Now, I'm looking at these bottoms. First of all, they are all fractions, okay? And second of all, let's figure out what W cannot be. First of all, W can't be 0, because if I put a 0 here, there you go, undefined. But what else can W not be? If I put a -2 in here for this W, -2 plus 2 is 0. So not only can W not be 0, W cannot be -2 either. So there are 2 numbers that W cannot be. Is that right, Visca? Yeah, that's fine. Anything that would make any denominator 0, our variable cannot be that. Okay, so we have our restrictions. Now, let's find common denominators. I cannot just add 2. I cannot say, oh, I'm going to plus 2 plus 2. Fractions do not. That is a no-no. Fractions do not maintain their value by adding, only by multiplying. What I'm about to write in purple, do not write. Again, our example, 1/2. If I add 3 to the top and bottom, I have 4/5. 4/5 is not 1/2, what we started with. If I multiply by 3, I get 3/6. That still is 1/2. So we need to find common denominators by multiplying, not by just adding. All right? Now, back to our problem. I have a W here. I have a W here. Wouldn't it be nice if I had a W bang, right there? Yes. So guess what? So I'm just going to put it, I'm going to multiply the bottom times W. What I do to the bottom, I must do to the top. Now, what about this W plus 2? I have a W plus 2 here. Wouldn't it be nice if I had W plus 2s here and here? It would. So guess what I'm going to do? W plus 2, I'm going to multiply it. W plus 2. What I do to the bottom, I must do to the top. Okay? Now, look at all the bottoms. Every bottom has a W, W plus 2. W, W plus 2. W, W plus 2. Guess what? Wipe out, they're gone. I only need to worry about the top now. 1 times W is just W, plus 1 times W plus 2 is W plus 2, equals 3 times W plus 2. Don't forget, we need to distribute. 3W plus 6. All right? Now it's just basic math. Okay, I have 2 W's. I have plus my 2 equals 3W plus 6. All right, so now I'm going to subtract 2W from this side. Bang. This becomes 1W. And I want to get rid of the 6 on the right. W is -4. Okay, is that one of our restrictions? No. So that works. Let's go on to number 4. Now, again, at any point in this video, if you want to start doing some of these on your own, go right ahead. Okay, go right ahead. I'm about to do this like a boss right now. I had mentioned earlier that factoring never goes away, and it does not. Okay, factoring never goes away. So we are going to have to use factoring in this problem here. So if you have polynomials on the bottom, expressions that are more than one term, meaning you have pluses and minuses in between them, factor them all out, because that's going to help you visually see what these denominators have in common already and what denominators need what terms. Let me explain. Okay, I'll rewrite this. Okay, 1 over 1, I'm going to make that a fraction, plus 30 over y squared minus 9 equals 5 over y minus 3. Okay, I know that y squared minus 9 is a DOPS. It's a difference of perfect squares. I know this is y minus 3 times y plus 3. Okay, that takes the place of the bottom. Now this becomes easy to look at. And what do I mean easy to look at? This has a y minus 3. This has a y minus 3. So why don't we give this a y minus 3? And that's exactly what I'm going to do. Y minus 3. Okay. What I do to the bottom, I need to multiply to the top. Okay, let's take a look at something else now. This has a y plus 3. This does not, so I'd like to put one here. Neither does this. Okay? So I'm going to put a y plus 3 here. What I do to the bottom, I need to do to the top. And I'm going to put one here. This would be y plus 3. Sorry, I'm running out of room. I need to do that to the top as well. Okay? Now look at all of my bottoms. They all have a y plus 3 and a y minus 3. Guess what happens when all the bottoms are the same? Done. They're gone. So all I got to worry about now are the tops. So I have y plus 3 times y minus 3 times 1. Okay? Oh, boy. I'm going to FOIL those. But let's leave them right now. Just y plus 3 times y minus 3. That's what we have here. Plus 30 equals, let's distribute that, 5y plus 3. Okay, right now, in order to solve for y, I need to get all my y's together, which means I'm going to have to FOIL this back together. Didn't this originally come from y squared plus 9? It did. And if you FOIL those together, you get y squared plus 9 plus my 30 equals 5y plus 3. At this stage in your mathematical career, if you see, well, I have a y squared, I have a y, those can't combine. I have numbers without y's, whatever. You have a quadratic. In order to solve any quadratic, you get everything to one side, and you're going to have to factor and solve, which is booty, cheek, and T-bone. Let's combine everything and go from there. Okay? Well, I'm going to subtract 5y and subtract 5y from this side. I'm going to subtract 3, boom, and subtract 3. So I now have, okay, y squared with nothing to combine it with on the left side. I have minus 5y, and I have nothing else with a 5y. Now I have 9 plus 30, that's 39, minus 3. 39 minus 3 is positive 36, equals 0. That doesn't seem right. Oh, oh ho ho ho. Oh ho 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 ho. Oh. What is 5 times 3? It's not 3. This should be 15. Maybe you caught that earlier and you're like, oh, Visca, I got you. If you were in my class, I'd give you a Jolly Rancher. If you ever catch me making a mistake in class, I give you a Jolly Rancher, which means this should have been a 15, which means we should have subtracted 15 to get rid of this, which means instead of minus 3 here, it's minus 15. So if I have 30 plus 9, okay, if I have 30 plus 9, it's 39 minus 15. 39 minus 15. What do we have there? Man, again, geez, a second mistake. I am sorry. I need more coffee. Oh, they're not with the y squareds and the y's. Man, if I were in class, I'd be giving away candy like a freaking leprechaun at St. Patty's Day. Okay, what did we say y plus 3 times y minus 3 was originally? Y squared minus 9? That's a minus here. So again, we're still combining our same 3 numbers. Wow, holy poop, sickle. 30 minus 15 would be 15. Minus 9 would be, and thank goodness, it's 6. Okay, thank goodness I caught those 2 things before we factored. That would have really stunk. All right? Man, look at you go. Look at you go. After I made that first mistake and I caught it and I thought I was all smart, I'm like, oh, I made the mistake. And you're like, yeah, Visca, you're stupid. That 9 should have a minus in front of it as well. This is why you're good. Okay? Let's factor this. I don't know if you can hear that police siren, but this is where I make a corny dad joke. Like, the math police are here. I made 2 mistakes. It's the math police. Anyways, let's booty chicken T-bone this. You ready? 2 numbers that multiply to 6 that add to negative 5. Oh, these are y's. Man, I am off my game. If this would have been a mistake I made earlier in the video, I probably would have just redone the video, but we're too far in now. We're committed, people. Okay, minus 3 and minus 2. If I multiply them, I get a positive 6. If I add them, I get a negative 5. So y would equal positive 3 and y would equal 2. Let's see if either of these are on our restriction. We didn't even write the restriction. What can y be and what can y not be? Y, first of all, if I look right here, I can't have y be 3. That would make this bottom a 0. Okay? And if I factor this out, I have y minus 3 and y plus 3. Y cannot be a positive 3 or a negative 3. Okay? If I have a positive 3 or a negative 3, that will make any of the bottoms 0. So let's look here and see what I got. Y cannot be 3. This is an extraneous solution. So I put a big line through that, and here's my one answer. Now, That was a lot of work, especially because I had to go back and check myself and found a few mistakes. Let me explain something to you, and I just said this in my last period class. Mr. Albert Einstein was probably one of the smartest people to ever walk this planet. Once said, it's not that I'm smarter than most people, even though I was. It's just that I stick with the problem longer than most people do. There might be a problem. Someone would spend 10 minutes on it and just be like, I can't do this. He would spend 4 days on it, but he would make sure he got it and got it right, just like we did. All right, this is the last one, and we are going to factor everything we need to first. The only thing that I can factor is the bottom left denominator. 2 things that multiply to 12 that add to -7. Okay, it's x. It's x. It is going to be -4 and -3. Now, let me take a look at what I have. Okay, I see an issue right away. You see I have this x minus 3, but I have this 3 minus x. Remember, if 2 terms are rotated around a minus sign, you can factor out a -1. So what I'm going to do is I'm going to call this x minus 3, but I'm going to put my -1. I always like to put my -1s on the top. So right now, I have times 2 times a -1. That will turn into a -2. So right now, we have -2 up here. Okay. Now let's look at all of our bottoms. All right, let's do this. Let's do this. We'll use the green one. Highlighter, highlighter. I have an x minus 4 here. I have an x minus 4 here. It would be nice to have an x minus 4 here. And that's what I'm going to do. I'm going to put x minus 4. What do I do to the bottom? I need to do to the top. All right? Now, what else do I have? I have an x minus 3, and then x minus 3 for the left and the middle, but I don't have an x minus 3 to the right. So I'm going to multiply that times x minus 3. What I do to the bottom, I have to do to the top. All right? With all of our denominators factored, it's also easier to see what can x not be. Well, I can't make an x4 because it would make this denominator 0, right? I cannot make an x3 because it would make this part 0. Those are my 2 restrictions. X cannot be 3 and x cannot be 4. All right? So let's get forward. All the bottoms are now the same. So guess what I'm going to do? X minus 4, x plus 3, x minus 4, x plus 3, x minus 5. Boom. I've got to worry about the top. 5 minus. Be careful with the minus sign because you are subtracting this whole thing. Okay? So I'm going to distribute my -2. I've got -2x plus 8. But I've got to subtract that. So I've got to eventually distribute my minus sign as well. 5 plus 2x minus 8. Okay? Equals, now I got to distribute this 5. 5x minus 15. Let's not forget 5 times 3 is 15. That's an inside joke between me and you because, I remember I made that earlier mistake. Anyways, let's combine everything and go from there. I have 2x. 5 minus 8 is -3 equals 5x minus 15. All right? Let's subtract 2x from this side. Subtract 2x from this side. -3 equals 3x minus 15. Let's add 15 to both sides. I now have 12 equals 3x. And if I divide by 3, x equals 4. But wait a second. 4 is one of my restricted answers. So guess what? Extraneous solution. It does not work. Wow. That was a lot. Now this one I'm just going to go over quickly. You can actually do stuff like this in your calculator. Okay? You can make the right side y1 in your calculator. Make this y2 in your calculator. And then you can use the intersection function. Okay? And Once you use the intersection function, you take your little spider dude, bug dude, that's what I call him, that's why I wrote this here, and you put it close to the intersection, hit enter 3 times. If I were to do this, I believe the answer might be 0. It would look something like this. You do this, this thing would come like this, down like this, and like this, and then this thing would look like this. This would have asymptotes, which we haven't gotten out. And then we have y equals 1, which crosses right here. Crosses right here. So your intersection would be right there, whatever that would be, and I would believe that would cross right at the point where x is 0. Okay? So I'm doing that quickly because we've done things like this before. But I just want to let you know we can do this in the calculator. The directions are right there. Set one side equal to y1 and one side equal to y2. If you want, you can make this y1. You can make this y2. That's fine. Graph them both, and then use the intersection function. It is worth its weight in gold. Thank you so much.